Welcome to section 3.1, continuing with solving system of equation. Today we're going to solve by the elimination method. So let's go to the first example. Now to clarify, you're not going to always have the question solve the system by elimination. Now the only way you would know or can tell that you're going to be doing elimination is when you examine the two equations within the system. In the first equation, notice how we have the x and the y on the left side of the equal sign. And then looking at the second equation, when you examine it closer, again, notice the x and the y are on the left side of the equal sign. So whenever x and y are on the same side for both equations, that means that you can do elimination, especially when you can see right away, for this particular example, the x's line up, the y's line up, the equal sign lines up, and the number lines up. So that means right away you can tell yourself, hey, I'm going to do elimination method. Now, in the event that one equation where the whole thing is flipped, the x and y's were on the right side of the equal sign, you can still do elimination. You just have to flip the whole equation. So when you flip it, make sure you keep the signs intact. So you flip the whole thing, so that way that the x and y's are on the same side of the equation. So again, here we can tell the x's lines up, the y lines up, the equal sign lines up. It's very important that the equal sign lines up, so that way you can tell where your x and y's are and where your numbers are. So when we're working on this problem, we're gonna examine the x and the y's. Now for elimination, before I do any kind of work, there's three criteria you have to follow for elimination. The first one is make sure that when you're comparing the two equations, it is the same variable. Once you identify you're working with the same variable, make sure to see if they have the same number. And then after that, if they have the same number, make sure they have opposite signs. So again, to be eliminated means to cancel out. So for anything to cancel out, they have to have the same number and opposite sign. For example, 5 minus 5, 3 minus 3, negative 9 plus 9. But again, to properly eliminate one term, they also have to have the same variable. It cannot cross variable, so it has to be the same variable. So x with x and y with y. So let's go over to our system. Looking at the x's, they both have the same sign and they have different numbers. So these two cannot be eliminated. They cannot cancel out. So let's move on to the y, see if they can be eliminated. I do see that they both have the 5, so they have the same number. And lucky for us, they have opposite sign. So the y's do cancel out. When they cancel out, then it will just be a 0y. Now I write 0y just in case if we're working with special cases. Now let's compare the x's since they didn't eliminate, they didn't cancel out. So negative 3x minus 9x, so I'm going to combine vertically. Negative 3x minus 9x, that would be a negative 12x. And then over here, it's negative 10. When you combine with a positive 10, you're adding it because it's positive. Negative 10 plus 10, that's a 0. So even though it equals a 0, doesn't mean it's a special case. You can still keep solving and find the value for the variable. In this case, we're going to be solving for x. Now, the reason I say we're going to be solving for x is because if I were to combine negative 12x plus 0y, the 0 doesn't change anything, so it's just going to be negative 12x on the left side, and it's going to equal to 0. Now, from there, to get x alone, I'm going to divide by the number that's in front of it, because the x is multiplying to the negative 12, hence that's why I'm going to be dividing by negative 12 to both sides. Now, if you have a 0 in the top of the fraction, you can actually solve it. You can simplify it. It's just the only time you cannot continue is when you have a 0 on the bottom. So x will equal to 0. And then let me box my first answer. So again, whenever you have a 0 in the top of a fraction, you can actually simplify it. You can actually keep going. Anything with a 0 on the top and you divide by any number, positive or negative, the outcome is always 0. So now in order to solve for y, you're going to plug into any of these two equations, but I'm going to plug in both of these equations, and then I'm going to show you the work. And if you do it properly, then you should end up with the same answer. So in the first equation, negative 3. Now we do know the value of x, so instead of x, I'm going to put in 0. Then bring the minus 5y, because again, I'm still doing the first equation, equal to negative 10. So negative 3 times 0 will be 0. And then I bring down the minus 5y equals to negative 10. 0 minus 5y, again, the 0 doesn't change anything, so it's going to be negative 5y equals to negative 10. So to get the y by itself, since it's multiplying to the negative 5, I'm going to divide both sides by negative 5. So again, I'm going to divide both sides by negative 5. So on the left, it will be a positive y now. Negative 10 divided by negative 5 would be a positive 2. So there's my answer. Let me box that up. Now to check if your answers are correct, you would have to plug into both equations to see if it's true for both equations. So that's all you have to do for system if you want to make sure that they are correct. Now I did the first equation. I'm going to do the second equation. So in the second equation is negative 9x, but instead of x, I'm going to plug in the value of x, which is 0. Then bring the plus 5y, because again, this is from the second equation, equal to positive 10. So negative 9 times 0 will just be 0. Bring down the plus 5y. Bring down the equal to 10. So 0 plus 5, again, the 0 doesn't change anything, so it's just going to be 5y equal to 10. Now, I'm going to divide both sides by 5 because the y is multiplying to the 5, and this one is a positive 5, so just keep that in mind. So again, I'm dividing both sides by positive 5. So on the left, it will be a positive y. Positive 10 divided by positive 5 will be a positive 2. So I plug in both equations, and we ended up with the same answer, y equals to 2. So as long as you do the work carefully and correctly, then again, you should end up with the same answer. If you have someone that used a different equation, so for example, you did equation 1, you had a colleague, you have a classmate that did equation 2, you should have the same value of y or the same value for x, depending on the problem. And again, if it's different, that's at that point, both of y'all should double check your work, see if you have the right numbers, the right sign. Now, I mentioned in substitution, you could write your answer in a different form. So you could write it as a quarter point. Remember, x comes first. So my x value is 0, comma, and then my y value is 2. So you could write like that, and then box your final answer. Now, if, again, you're working with different letters, then just make sure to put in alphabetical order. So that's all you have to do for elimination. As long as you follow these 3 criteria, same variable, same number, most importantly, opposite signs, then you can eliminate one term and then solve for the other. All right, so we have example 2. In example 2, we have negative 2x minus 9y equal to 0 and 2x plus 9y equals to 10. So I see that for both equations, the x and y's are on the same side. They're on the left side of the equal sign. So I can use the elimination method. So what we're going to do when we're working out these is we're going to analyze each term vertically. So let's take a look at the x. Both of them have the same sign. Same number, excuse me. So let me repeat myself. Both of the x's have the same number, but they have opposite sign. So this one is a positive 2. So since they have the same number and opposite sign for the x's, then these two will cancel out. Excuse me. So when it cancels out, it will be a 0x. Again, I'm writing the 0x in case we're working with a special case. Now let's take a look at the y's. Similar, they have the same number, and also they have opposite sign. So found the criteria, same number, opposite sign, then the y's will be eliminated. They will cancel out. So I'm just going to write plus 0y. Now, it doesn't matter if you write plus 0y or minus 0y. Again, with the 0, when you're adding, subtracting, it doesn't really change anything. Put the equal sign. Here, it's a 0 and a positive 10, so I'm going to put plus 10. So 0 plus 10 is 10. So I end up with a 0x and a 0y. So this is indeed a special case. So if we refer back from substitution, in substitution, I talked about how if you have a 0x and it equals to a number, say negative 3, or you have a 0y and it equals to, say, a positive 2. If you have a 0x or a 0y that does not equal to 0 but a number besides 0, then these two scenarios are considered a no solution. So let me write that out, no solution. So even though it's just a 0x or a 0y, over here from elimination, we have a 0x and a 0y. So in the event you have a 0x and 0y, this is where now we're working with special cases. Since we have a 0x and a 0y and it equals to a number besides 0, then this is where you would stop. And then you just write no solution. I'll box that up. Now, I'll explain why this is considered a no solution. Now, let's pretend that x is 1 and y is a negative 4. So working this out, it's a 0 times my x value, which is 1, plus the 0y. So instead of y, I'm going to plug in -4. And supposedly it equals to 10. So 0 times 1 will be 0. 0 times -4 will be 0. And supposedly it equals to 10. But 0 plus 0 is 0. And supposedly it equals to 10. Well, we know that 0 does not equal to 10. Again, the only way you have a true statement is if it's either 0 equal to 0 or 10 equals to 10. In this case, we don't. So that's why, regardless of whichever x value that you use and whichever y value that you use, no matter which one you use, it's going to be a false statement, because with 0x and 0y, the left side will always come out as 0, and it will never equal to 10. So that's why you have no solution. So this is the work explaining why you have no solution. Now, this is one special case. Now, the other special case, if you recall from substitution, I mentioned about how if you have like a 0x and it equal to 0, or a 0y equal to 0, then these two scenarios is considered as infinite solution. Excuse my handwriting. So again, from substitution, if you have like a 0x equal to 0 or a 0y equal to 0, then you would stop there and then just determine it as infinite solution. Now, for elimination, in the event if you have like a 0x plus or minus a 0y, and if it ends up with equal to a 0, then it's similar to the no solution special case, but since it does equal to 0, you would stop here, and then you would just write infinite solution. Oops, excuse me. So, as I was saying, in the event when you're eliminating, just like how we did in this example, if you end up with a 0x with a 0y and it does indeed equal to 0, then you would stop the work and then you would just write infinite solution. But again, before you box your final answer, make sure that the terms did indeed cancel out, indeed were eliminated. If that is true, then that means you are finished. You would just write infinite solution and box it, and that's all you could do.